Hi, thank you for joining us today. This is the Basics of Building a Search Strategy webinar part 2, Translating Searches to Other Databases. I'm Rosie Haneke. I am Associate Professor at UIC Library of the Health Sciences. I'm also the librarian for systematic reviews, and I'm co-presenting today with my colleague Amelia Brunskill, who's Assistant Professor and Information Services Librarian. She's the liaison to the College of Applied Health Sciences at UIC. What we'll be going over today is a brief refresh of last week's webinar, part 1, Building an Initial Search in PubMed. If you haven't viewed that recording, I would recommend that you go back and view it to get some basic principles and fundamentals that we're going to be building on today. We'll talk about the underlying principles of translating your search, how to choose which databases to search. We're going to talk about the differences between platforms and databases and why that matters, steps involved in translating a search from PubMed to other databases, some tools available to help you with this, and we'll talk a little bit about exporting your references from databases to your citation manager. So please note that parts of this webinar have been re-recorded due to some technical difficulties we had during the live session. So there may be some minor differences from the webinar that was given on March 5th of 2024. Starting with a brief refresh of what we talked about in part 1 of this 2-part webinar series. Last week, we chose an example research question and used that to demonstrate how to build a search strategy around this question. And the example we used was, how do the social determinants of health impact physical activity in urban environments? As you'll recall, the core building blocks that you're going to use for your search strategy are keywords and controlled vocabulary terms. Keywords are any search terms that you can think of that describe the core concepts of your research question. So for example, population, intervention, exposure, patient, etc. And most databases will search for these terms in an article record, so not the full text of an article, but it'll search in the title, abstract, and some other fields. And as I said, you can search any word you like as a keyword. In addition to keywords, you're also going to be building your search using controlled vocabulary terms. And these are the official standardized terms used by each database to tag the major concepts in an article. In PubMed, we mentioned these are called mesh terms, but most databases have their own version, their own controlled vocabulary. You might hear us use the phrase subject headings, and this is another type of controlled vocabulary. So these are standardized terms that describe a certain topic. And remember, we're going to use these to make sure we're capturing all the literature on our topic, regardless of what vocabulary an author might have used in the title and abstract. We chose an exemplar article that would fit our inclusion criteria for this hypothetical review. And then we looked up that article in the PubMed database to pull out those controlled vocabulary or mesh terms to save to our search. So these are the terms that correspond to the major concepts in our research question. We put those into a table along with keywords describing each of our 3 major core concepts of our research question. So you'll see behind each term is either MESH for mesh, for the terms that we have identified as belonging to that standardized vocabulary in PubMed. And any other terms we want to search, we're searching in TIAB, which is the title and abstract fields. And this is what that search looks like when we put it together with Boolean operators. We have 3 concepts, and each of those concepts is set apart within parentheses with keywords and mesh terms describing that concept separated by or. In between each of those 3 concepts, we have and, meaning that we want PubMed to locate all of the articles that contain at least one of the red terms, at least one of these purple terms, and at least one of the green terms in the 3rd bottom concept. This is another way to visualize a search after we've built it in PubMed. It's the same as on the previous slide, just line by line. So just another way to look at combining a search together in a database. What are the underlying principles of translating a search after you've built an initial search in a database like PubMed? First, and probably most important, you want to make sure you're using the same approach for each database to the greatest extent possible. So you want to keep the search as alike as possible from one resource to another. You're going to keep the main search concepts the same. You're not going to be adding on, changing, or removing a concept. In our case, that would be social determinants of health, urban and physical activity. You're going to keep all of your keywords the same. What's going to change is that TIAB code in brackets that we saw after each keyword in PubMed. That is going to look different for each database, and Amelia is going to talk about that more later. The structure of your Boolean operators, those ands and ors, that will stay the same. You're not going to be really moving those around or using them differently. And if you applied any filters or limits to your search, which is not a requirement, but if you did limit by language, date, study type, etc., you're going to want to apply those same filters and limits in every subsequent database that you search. And one caveat for today's webinar is that we are talking about standard bibliographic databases like you would find to be searched through the UIC library. And these principles aren't always applicable to trial registers, websites, and other types of gray literature sources that you might be searching for your review. The next webinar in this series will cover searching gray literature sources. Number two, search each database separately. Even though there are ways to combine databases and search them together, in the interest of full transparency, comprehensiveness, and reproducibility for your reader of your review, we're going to search each database separately. One major reason for that is that those controlled vocabulary terms differ from one database to another. So even if you can search Medline and PsycInfo through the same combined search in a given platform, it's not going to work properly because those two databases have different controlled vocabulary terms. And here we have an excerpt from Cochrane Handbook, the guidelines for systematic reviews of interventions, saying that we do need to customize search strategies for each database. The third principle is that make sure you document the exact search that you used in each database, including the database name and platform. We'll talk about what that means in just a minute. What terms did you use to search, and what fields, meaning title, abstract, controlled vocabulary, etc., what fields did you search those terms in? What Boolean operators did you use to combine them? And what limits or filters did you apply? As per the most recent version of the Prisma reporting guidelines for systematic reviews, your final published review should include a reproducible, copy-pastable search strategy for every database that you searched. In previous versions of these guidelines, it was best practice to provide your PubMed or Medline search strategy and then just say this strategy was translated to other databases, but that's no longer the case. You want to be sure you're saving every search exactly as you ran it in every database. So now that we know we are searching multiple databases, how do we know which ones to choose? There are no real hard and fast rules on how many you should search. Well, I guess the only hard and fast rule is that it has to be at least two, and generally it's three or more. Sometimes people do many, many more, but this depends on a lot of things. What is your review question? How specific and narrow is it? That literature might only exist within a certain narrow field, in which case there might be only 3 or 4 databases you could search. What disciplines cover this topic or study this topic? If you're looking at an interdisciplinary, maybe social science issue that laps into many different areas, you might be searching many different databases to make sure you're capturing literature from various disciplines. And then finally, what resources are available to your team? And by that, I mean what databases are available for you to search, but also what's your timeline? How much time do you have? So that may impact how many databases and which databases you search. Pay attention to other databases that were searched by authors of similar reviews or reviews in the same general discipline. If you look at Cochrane reviews, what databases did they search? You can ask colleagues for advice of where they have luck finding literature. You may choose databases to counteract the sometimes Western bias or English language bias of some of our standard databases. So you might take that into account. And another thing to look at would be which journals publish on this topic. What journals are likely to contain articles that would fit your eligibility criteria, and then what databases include those journals and search those journals. So a librarian is happy to help you with that. And any other questions regarding which databases you should be searching, you can consult a librarian for that. Some of the most common databases you'll see searched for systematic reviews in the health sciences, PubMed definitely, which contains a database called Medline. You may also see Ovid Medline searched in a lot of reviews, but because PubMed contains all of Medline, you don't need to search both of those. But typically in health sciences reviews, you will search one or the other. Embase is another go-to database for health sciences searches. And then we have CINAHL, which is nursing and allied health literature. Then if you want to look at literature from a specific discipline, you might look at a smaller disciplinary database such as APA PsycInfo, Sociological Abstracts, Econ Lit, maybe an education database, depending on your topic. And then the final category of databases is what we would call multidisciplinary citation indexes. The two that we have at UIC Library are Web of Science and Scopus. These are large databases that pull records from all different disciplines. So not just the health sciences, social sciences, even arts and humanities. What we're talking about today is not really going to apply to Google Scholar simply because that database is an outlier when it comes to databases you might search for systematic review. Google Scholar does not work the same way as more traditional scholarly databases like the ones we're going to be talking about today. Its search algorithm is not transparent, and it can be hard, if not impossible, to repeat the same search twice. It often generates tens or even hundreds of thousands of results, making it impossible to review every record as you would do for every other database result in a systematic review. And it does not support exporting all of your results in a single mass batch. If you want to do that, you have to use a third-party tool. So we want you to think of Google Scholar as, if you search it, a supplementary search method rather than one of your primary database search resources. And that's because although it is a valuable database in many ways, it is incompatible with the core principles for systematic reviews of transparency, comprehensiveness, and reproducibility. If you search Google Scholar as a supplementary method, you can state in your methods of your review how many records you reviewed. So often a standard you'll see is that a team reviewed the first 200 results from Google Scholar, or for smaller results where their other databases have very small result sets, they might look at only the first 100. But either way, you're not looking at all of them. And then we need to clarify a minor but important distinction between databases and platforms. Databases are searchable compilations of records for various publications, such as journal articles, books, book chapters, dissertations, and more. Each of these records contain metadata or information about the article or about the publication, and that would include author, title, date, not the full text of the article. So examples of databases are PubMed, Embase, CINAHL, ERIC, which is the major education database from the US Department of Education, and Scopus. Platforms, on the other hand, are user interfaces that come from a specific database vendor or company. A single platform can be the interface for searching multiple databases, a single database within a collection, or a combination of databases. And what databases you can search on a given platform depends on what databases your institution subscribes to. So the most common platforms you might see are EBSCOhost or EBSCO, ProQuest, and Ovid. For systematic review, you always want to search individual databases rather than an entire platform. And that is because, again, you're aiming for reproducibility, and a reader from another institution might have access to the same platform, but their database coverage could vary entirely. So they wouldn't be able to reproduce your search without knowing which collections within that platform you searched. And also for reasons of precision. So if you're searching multiple databases across a single platform, you can't use the database specific search options like controlled vocabulary or subject headings. You're going to be searching databases and collections that are not relevant to your research question. And as a result, it's going to introduce a lot of noise into your search, a lot more irrelevant results that you have to wade through. There are some databases such as Embase, ERICS, Medline, and PsycInfo that are available to you through multiple platforms. In many cases, a library will only have access to a database via a single platform because that is a subscription database. So, for example, we have Embase through Elsevier. We cannot search Embase through the Ovid platform, as can some researchers at other universities. In some cases, we might have access to a single database via multiple platforms. So we have access to ERIC, that education database, via ProQuest, EBSCOhost, First Search, and the Department of Education. The search syntax for every search is going to be different, no matter, even if it's the same database, it's going to vary by platform. Here's an example of what ERIC looks like on ProQuest, and here's what it looks like on the EBSCOhost platform. Same exact collection of records, two different platforms. So again, for the objectives of reproducibility and transparency, you need to specify in the methods section of your review both the specific database that you searched and the platform you searched it on, so that researchers at other institutions will be able to either replicate your exact search if they have access to the same database and platform, or they would know that they can't simply, if they have that database on a different platform, they would need to translate that search syntax to be able to reproduce your search. This is an example from a recent review that we did at the library showing database names and the platforms that they were searched on. So it's a lot of detail, but this is in accordance with current guidelines and best practices for reporting out your search strategy. And then as you can see, we put the full search strategy, all terms and Boolean operators in an appendix.
Great. Well, thank you so much, Rosie. So I'm going to be talking now about steps for translation. Okay, so as mentioned, so with keywords, you're going to be searching for the same keywords in each database. However, the formatting will differ. So sometimes we say formatting, sometimes we talk about sort of search syntax, but just, how we put in those terms, any formatting we put around them to indicate how they should be searched. So from our original example, these are the keywords stripped of any specific formatting. So we have for social determinants, we have our list for physical activity and for urban, and these same keywords are going to be searched in all of our different databases. So for PubMed, we talked about using the field code TIAB, that's in brackets, for terms in the title or in the abstract of an article. And just as a note, you'd think that title and abstract was very clear. It's actually a little bit broader than that. It actually includes words in the keywords, author keywords as well, and some other things. So it's a little bit broader, but basically the title and the abstract. So for the other databases that you're translating it to, you're going to try and select the field codes. And the field codes just means that the code that indicates what specific field is going to be searched in, according to that database, that is closest to your selection in the original database. And you're also going to use the database platform formatting indicated in order to search in those fields. So some databases have a field code that includes the title and the abstract, or the title, abstract, and keywords, which again is also fine and commonly done. In others, you might need to use separate field codes for the title and the abstract. They might not have anything that directly pairs the two of those. So here are some keyword formatting examples. So we're using one of our keywords, poverty, in this example. So in the Embase Elsevier platform, we do poverty, TI, AB. So we're searching both the title and the abstract fields, but this one, even though they're separate field codes, it makes it easy to say, okay, this keyword in both of them at the same time. CINAHL on EBSCOhost, you have to do it separately. So you have to say TI, parentheses poverty, or AB for abstract, parentheses poverty to get for title and for the abstract. So you have to say, I want it to be searched in either of these two places. Web of Science combines it with this TS, which is a topic search, which searches the title, abstract keywords, and their keywords plus thing. And again, that's TS and then equals, and then just in parentheses, poverty. So you just put the keyword there. Scopus, it's title hyphen ABS for abstract hyphen key for keywords, and then the keyword in parentheses. So they all look a little bit different, but function very similarly. There's no perfect way to make sure it's searching the exact same set of metadata in each database, just because they've all made slightly different decisions about how that's handled. But you're trying to sort of be as close and consistent as possible, and also documenting so it's very clear what was searched and how. So phrase searching. So many, but not all databases use double quote marks for keeping two words together. So, for physical activity, double quotes saying, yes, we want it to not just search physical, and activity, we want to look for that specific phrase. Those words kept together. So of course, though, there have to be some exceptions and quirks. So here are some of those. Embase on the Elsevier platform uses single quotes. In Scopus, you can actually search for a phrase two ways. One is what they call a loose phrase. That includes common variant spelling, so United States and UK, also plurals. So under that, the double quotes for color theory would include color theory with an O and also with the OU, so the British spelling and the American spelling. It would also include theory and theories. So it's a bit broader, but if you want a strict phrase search, then you use curly brackets. At least historically, some databases have either not supported curvy quotes at all. So like it look like when they have that curve to them, sometimes they say it's an unsupported character and you have to actually go in and change it, and it literally won't let you run your search. Or they might interpret them differently than straight quotes. And I have at the bottom, there's just a citation where some people have gone in and looked and seeing what all the different, how that plays out in different databases. So just something to be aware of. Sometimes even those little distinctions sometimes matter. Okay, so subject headings. So unlike keywords, the same subject headings cannot simply be reused from your initial database search string and just changing the formatting. You have to check what subject headings are available and are the best fit for each database for each of your concepts. So here, this is an example for original PubMed search. So we have our concepts, and then underneath are the subject headings that we found in PubMed for each of those concepts. However, when you're going this, you want to sort of start on the concept level to see what the match is for that, rather than trying to translate it from your initial search, because sometimes your initial database that you used didn't have sort of sometimes ideal fits for the concepts, and some of the other databases might have better fits. So when you're looking for subject headings for each database, the first question is, does the database even use subject headings, or at least ones that are going to be useful in a systematic review? More subject-specific ones like PubMed and CINAHL commonly do. They're really trying to provide very sort of um, focused ways of being able to address the literature and cover all of the um, concepts there. Very multidisciplinary ones, however, like Web of Science and Scopus, often do not, or have incredibly broad ones like medicine or chemistry. They don't have often sort of a very controlled vocabulary that has been applied across all of the literature that they include. So if a database does use subject headings, how can they be found? So there's two ways, and we recommend using both, as we did in PubMed in the previous session. So just fresher, so one of them is by searching through a dedicated listing of these terms provided by that database, sort of like a database within the database of these terms. These terms and their listings, they may be sometimes referred to by different words, sometimes thesaurus or index terms or subject headings list. And in some cases, they may have a set name, such as we saw in MESH, so medical subject heading, which is used in PubMed/Medline. So that's one way. Another way is by looking at records for specific articles, such as your exemplar in the database, and seeing what subject headings are listed on its records. Both of those can be really helpful because sometimes you find useful ones in one approach that don't show up in the other. So they both are useful tools. So considerations when looking at subject headings. So does the database have an exact match for your concept of interest? And we don't just necessarily mean just the term itself, but does the term itself, let's say sort of physical activity, does that encompass everything that you have in mind when you specified that concept? Or sometimes might you need to select multiple subject headings to get better coverage of that concept. Maybe it's not all in one under one subject heading. Maybe you have to pick multiple ones. You're also going to want to think about, should all of the narrower subject headings that fall underneath a chosen subject heading also be included? So when you do, we call that exploding, saying we want everything that's underneath as well as that higher level concept. And if not, then you haven't exploded if you just keep the subject heading that's at that initial level. PubMed defaults to exploding, but a lot of the other databases you have to actively select if you wish to do so. Okay, so subject heading systems by database. So some examples. Because as you mentioned, there's many databases, so we can't cover all of them, but these are some of the big ones. So just Scopus, it doesn't really have its own subject heading, at least not one is sufficiently well-defined and granular enough to be useful in the context of systematic review searching. Embase, the system that they use for subject headings is called Emtree. CINAHL is CINAHL subject headings. ABA PsycInfo uses what they call a thesaurus, the APA thesaurus of psychological index terms. So just wanted to go through some screenshots for a couple of different databases just to show you how to find them when you're in the database. So Embase, the link to Emtree is at the top level menu. And if we click on that, if I do a search for physical activity, you can see we get this tree, and you can see that everything, all the narrower subject headings that are underneath it as well. So if we wanted to, on the right-hand side, there's options for like, do we want to explode it? So we have the explosion, you can see that gets a lot more than if you just pick it as index terms of keeping it just that higher level one. But if you look at it, you might say, yes, maybe we want, climbing and cycling and, jogging and all these different types of physical activity. You might also check and look through and say like, oh, there's some things that maybe aren't included and I want to check and see if they are somewhere else, and that I might want to include those as well. And now this is an example from our exemplar in Emtree, in Embase. And then if we look at the record and then we open up that index term, then we can see all of these different index terms that have been associated with the subject heading. And if you clicked on the little sort of diagonal 3 dots next to one of them, you'd get to the entry record. CINAHL, again, it's at the top, so CINAHL subject headings. If you click on that, and then here I've done a search within it for physical activity, and then this is what comes up. So, it is an exact match, in terms of physical activity, in terms of the term, but we'll see that under the explode option, so again, you have to opt into exploding, it's actually grayed out, which means that there's no narrower terms listed. That might be a little bit surprising. We saw in Mtree that there were a lot of different terms. So again, you might want to do some additional searching and saying like, okay, maybe we want this one, but maybe there's other ones we want as well, or maybe we need to go higher up in the tree to capture more. In APA PsycInfo, there's a link to the thesaurus at the top. And then here is an example of I've done the search again for physical activity. And here I've also then, when I found it, I've double clicked to see where it falls in the tree. And again, this time, there are some narrower terms that are included underneath. But for example, under exercise, there's only 3 listed: aerobic exercise, weightlifting, yoga. We might be surprised that things like swimming and cycling and jogging aren't included. And we might want to see, is there no subject heading for those, or are they included somewhere else? Is there perhaps something else, like, sports, or somewhere else that those might be included, and perhaps we want to add them as well. And again, we have to actively click to just on the explode in order for anything underneath to be included. So in terms of the formatting or the syntax for the subject headings, that's going to depend on the decisions that you make about whether or not to explode a term. But the important thing to remember is that you don't want to just put in a subject heading without specifying that it should be specifically searched that way. So it's not enough to just find it. It also has to have that special formatting. So here are some examples of formatting. If you were for exploded subject headings, you'll see that in a lot of these, there's something, so like in Embase, that it's /exp for explode. For the CINAHL one, there's a plus after physical activity that indicates that it's exploded, so including everything more. And then in the APA PsycInfo one, main subject exact explode. So it's often pretty clear when you see them for those ones where you've had to opt into the explosion. So proximity. So if, in your original search, you said, okay, there's some terms that you want to have a relationship, but you don't want them as exact phrase, but you want to have a maximum distance between them, say that they should only maybe be 3 words apart. That, you have to translate that as well, because proximity searching, again, has different formatting and slightly different sometimes meanings between databases. Sometimes some of the decisions that you have to make is if the database has the option, should one word come first, or should they come in either order? So whatever your expectations or hope in terms of controlling that. For example, it's possible for social determinants. You might say like, well, there might be words between social and determinants that might come up, but I would always expect social to come first. Or it might be something like health professionals, where you might say, well, these are very connected concepts, but they might come in either order. So you might see people talking like, we studied health professionals, or we studied professionals in the health sciences. Again, they're very close together, but they're not always appearing in the same order. It's also good to pay attention to what the specified number means. Between the words, sometimes one means 1 word between, and sometimes one means no words in between, but they're right next to each other. And for those interested, we have information, more information on proximity operators in different databases available on one of our LibGuides. And you're also always welcome to talk to a librarian about something like that. Hedges. So if you're using a hedge, so in your original database, search hedges are pre-existing combination of search terms that are used to retrieve records in a way that's intended to be comprehensive. It's often used to retrieve by study type, so like randomized control trials, or sometimes by research topic. They've been compiled by someone. Often they've been sort of tested. Ideally they've been tested and validated to see how effective they are. However, usually they've been tested in a certain environment, or sometimes maybe more than one, but often, sometimes might just even be in sort of one database. And they'll have said like, okay, in this particular database, we have numbers about, its sensitivity and specificity. But often they may rely on things like subject headings or publication types that exist in that one database, but may not be transferable between other ones. So it may not be possible to translate a validated search hedge to other databases at all, or even if it could be, it can't be assumed to have the same level of sensitivity or specificity. So you should proceed with a lot of caution there. And ideally, you would just use ones that there's a version for the database you're using on the platform that you are using. If not, you may need to rely on manual screening in your systematic review tool instead of trying to filter for that study type or topic ahead of time. And again, we have more information on search hedges in one of our LibGuides. Okay, so some tools. So there are some tools that are intended to help with translating searches. Big caveat at the beginning, nothing that I'm aware of can directly translate from a subject heading available in one database to subject available in another. So there's nothing that's able to check like, oh, this is a subject heading in PubMed. Is it also available in Embase? Even if it could, you would want to check whether the selection was truly the best fit in terms of the scope and other available subject headings. One thing that I forgot to highlight, but a lot of the thesaurus and index and subject headings listings, when you're looking for those subject headings, there's often what's called a scope note. They're saying, this is what we are, how we're defining this subject heading. And it's really good to sort of pay attention to those, especially when there's, possibility of more ambiguity. However, there are things that can help with translating in terms of formatting and syntax, and that can be really helpful. So 3 tools that we're just going to talk about. There's some word macros. There's something called the polyglot translator. And then there's an Excel spreadsheet that I developed a little while ago. Brammer's word macros is what I'm going to talk about the least, because I must admit I have very little experience with this. I don't tend to use a lot of word macros, but I just like to highlight that it exists, because what it is, as you'll see here, they created a query in Embase, and then they created macros that you can use to start from that query to translate it into other databases. So if word macros is something that you enjoy experimenting with, it's worth looking at these. And we're going to, again, give you a link to their listing there. I'm not sure how often they've been updating it, but again, could be worth a look. The Polyglot Search Translator. It's hosted and produced by the Institute of Evidence-Based Healthcare at Bond University in Australia. It's part of their larger Systematic Review Accelerator webpage that compiles a lot of tools that are intended to be helpful with automating different parts of the systematic review process. It lists translation options for a lot of different databases, and there's a full list down here. So this is a screenshot. So how it works is you put it, your search string at the top. So here's the one that we were using for PubMed. And then below, you pick the database and platform that corresponds with what you're hoping to use. So here we have, I have open at the bottom, the Embase one on Elsevier. And you can see it doesn't know in terms of how to translate the subject heading into, whether something is also available in an Embase, but it does know, like, for a subject heading, this is how it should be formatted. So it takes it from, mesh to the exp. So it's defaulting to explode in Embase. For title and abstract terms, it's doing the colon ti, comma, ab. It's translating those things as it should. So sort of some, just general thoughts about pros and cons. I find it's really nice and easy in terms of being able to just paste in a full search string and then seeing what comes out. It's also great to experiment with if you have lots of concepts or if you're using proximity searching, and sort of seeing, like, can it give you any potential sort of guidance on what that would look like. Cons, it looks like you can just translate the subject headings when that has to be done manually. At one point, they had like that more, it's sort of, I can't remember if it was literally in red, but they gave a little bit more guidance on that. They do seem to be sort of actively working on it, so that may come back again. But at least when I was more recently working, there was nothing really that seemed to be giving me a reminder that I would need to be doing that myself. Some of the distinctions it makes for search options weren't very clear to me. So there's one for Web of Science versus Web of Science Advanced. I think there were two, for Scopus, two for PubMed, and sometimes I wasn't seeing any information on like, oh, when should you pick which? But some of them didn't use field codes. And some of the decisions may not be the ones that you would want to make because it's automating, it's applying the same logic to everything. So my Excel spreadsheet is intended to be used to create search strings after all the keywords and subject headings have been identified for a given database. So we have it listed in one of our libguides, and there's also a 8-minute video about how it works. I'm going to go ahead and just talk through a screenshot of it for broad overview. So basically, it allows for sort of 3 concepts, and for each concept, there's 3 columns. And this works, it's the same way for each database, and you'll see that each database is listed at the bottom. So there's a tab for a lot of different databases. So you pick the database of interest, and then I'm going to talk through the PubMed example. So for each concept, in the first column, you just put, without any formatting, the subject heading for the concept at the top, and then underneath you put the keywords, and you put them just as a column, one per cell in Excel. And then what happens is in that second column, there are formulas that add formatting. And so in the third column, you copy and paste it as text only, because we don't want the formulas in it. We just want what the formula has done, so the formatting that it adds. And then in column N, you'll see that there is, for each of the columns, each of the concepts, it adds together all of the different terms, both subject headings and keywords that have been listed for that one. So it always takes from that last column where it has the formatting and there's no formula anymore. And then there's after that, and it just puts ors between all of those terms. And then there's another formula that puts those all together. So it takes the one for each concept, puts parentheses around it, and then puts and in between it. So we have concept 1 and concept 3, concept 2 and concept 3. And it just makes one big search string that then you can use. So some pros and cons. It can be very helpful to create an initial search. So sometimes you need something to be translated. You need to, so you create that one first. It's specific to what databases and platforms we have access to at UIC, because that's all I have access to. So there's not as many sort of decisions that you necessarily need to make there. It's potentially also more obvious that subject headings should not be reused. Cons, it's definitely more clunky, involves more manual work than the Polyglot Translator. It's designed for 3 concepts. It's not particularly flexible, doesn't handle proximity or apply fill codes that are not about keywords or subject headings. So if you have things like publication type, publication date that are included in your search, it doesn't know how to translate those. And again, some of the decisions may not be the ones that you would want. So it, defaults to sort of exploding all their subject headings. That may not be the decision you want to make for your search. So in terms of exporting, just quickly. So once you've created your search, you've run it, and now you want to get it into your citation manager or into your systematic review tool. So what you want to do is you want to make sure that you're exporting all the results for your search, not just accidentally into the first page or the first 100, but all of them. Exporting to a format that can be ingested by your citation manager and or systematic review tool. When possible, RIS format tends to work well. PubMed, though, I think it has its own formatting. When given an option, make sure that your export includes the abstract. Many of them default to including the abstracts. Some of them do not. I believe Scopus, you have to specifically select for it to include the abstract. Keep track of how many records should be included, and when you did the search, you're going to need that when you did the search for when reporting. And also, for sort of quality control, just making sure, okay, I'm expecting to have 750 from this search. Is that what I get when I put it into EndNote or when I put it into Covidence? Is that what I'm getting from this file? Some databases or platforms will make you create an individual account within the platform to download either any results or results over a certain number. We have videos on exporting for PubMed, CINAHL on EBSCO, Medline via Ovid, and PsycInfo on ProQuest. And they're all, again, linked to on one of our LibGuides. Before we pause for questions, just want to give you our contact information. So my email is abronx2@uic.edu. Rosie is rhaneke@uic.edu. A recording of this video will be sent out later this week. Next week's webinar is on gray literature searching. So lovely to see you again if you're interested. And we'd also love to get your feedback about this webinar. So we have an evaluation link that we're going to be putting into the chat. So we really appreciate if you can please take the time to fill that out. Great. Rosie, anything else you'd like to mention before we move on to questions?
No, I don't think so. I'm going to stop recording.